So we can work us all along.
2 items today, 2 more formulas for you to memorize.
Okay.
We will update our memory cards next week upon my return. Or we can do it at the end of class, I don't care.
Let's do it next week.
Okay, so polar arc length is going to be very similar to the arc length that you know already, the 2 of them, right? We have arc length rectangular, parametric, and we're going to have polar. They're all very similar. Okay, so that'll make that easier. And then slope in polars is quite involved, actually, but it's very similar to parametrics. There's just a little bit more work than that on it. Okay, so polars are really neat because they can model some things that rectangulars cannot, because we can have these funky shapes, right? So let's say you have a landmass and you can model it with a polar equation. What is the circumference, or the perimeter, I guess I should say, it's not a circle. What's the perimeter of that piece of land? That would be arc length. Polar arc length. Looks very similar to the ones you already know, right? One of them is 1 plus f prime of x squared. One of them is x prime squared plus y prime squared. Very similar in that respect. They're all derivatives of each other. Okay.
What's that bottom thing over
Alpha?
Yeah, alpha to beta. We're in polars, use a lot of trigonometry, so we use the Greek alphabet and trig, so that's what we use in polars. So let's look at r equals 2 cosine theta. Do you remember what shape that is?
It's a circle, right?
Yep.
With a diameter of 2
Circle, diameter 2, placed where?
on the order. You want to come to?
Remember, what is cosine related
0,
to
1.
x-axis, right? So here's your circle. Now, is there a very easy way to find the circumference of that circle?
Yes.
Yeah, there is. You know the answer? No, that's area.
2 pi r.
2 pi r. Okay. So now, if you get something like this, that's the way I would go. All right. It's the easy way to do it. So. But half the time, most of the time, what we're going to ask you for is just to write the formula. Okay, so let's say we write the formula to find the circumference of this circle in polar form. Right? Because that's probably what a multiple choice item is going to spit at you. Okay, so what is, okay, so we have f at theta here, right? You could put r here and r prime as well. Doesn't matter. What is the derivative?
Negative 2 sine theta. So,
That would be our f prime of theta, right?
With these, does it, when we were doing like revolution stuff, we would have to split up the integral if the thing was stacked on top of each other? You have to do that with this one? You know what I'm saying? Like there's a curve from 0 to 2 that's above the x-axis, and there's a curve from 0 to 2 below it. Does it matter if you split that apart?
We don't need to here.
Oh.
And then again, remember, the battle with these is finding these limits of integration. So what do you think? If theta is 0, what's R?
2.
2. Okay, so that means we actually start right there. It's like a unit circle, correct? What about pi over 2?
0.
0.
Oh, you played.
Pi over 2, cosine of pi over 2 is 0.
Oh.
Okay. And then pi, cosine of pi,
-1. So -2.
negative 2. Does that mean we're done?
Gotta get back.
No, you gotta go back to 2.
Gotta get back to 2 and 0.
We're at 2, 0.
Oh, because, okay, this pi came
Oh.
0.
Pi,
See.
Yeah.
which are negative 2 in the radius.
Yeah.
Remember how to use polar coordinates there. Right. So we are actually not, so our interval is 0 to pi on this question. You want to see a little algebra?
Sure.
2 squared is 4. Negative 2 squared is 4, right? So I can factor those out. And what's the square root of 4?
2.
2.
Is it gonna be?
And then,
Isn't that not gonna be?
yes, it is. What is the identity?
Oh.
Cosine squared plus sine squared is?
Isn't that tangent squared?
No. It's easier than that.
1.
1. That's 1. So you get, integrate, you get 2 theta from 0 to pi, which is
2 pi.
2 pi. Hey, look at that. We did it the hard way.
That's cool. Math works. I mean, what was the easy way? Where's the answer? The 2 pi.
Circumference,
2 pi r.
the radius of 1. Yeah.
So when you do it the hard way, you use that 2 pi, and then what do you do with it to find the?
That's arc length. That's the circumference of that circle.
Where's the r though?
R?
Yeah. Well, you need like.
You good?
I gotta look into this.
No, I think the answer is no, but
No, I think I'll get it eventually, maybe.
like I said, this is usually about where they ask you to go. One of these two would probably be your choice answer.
So is it always going to be, if it's constant trig, it'll be a circle, or is it just cosine? Because like 2 cosine theta is a circle, but cosine 2 theta isn't.
Right.
So does that work with sine as well? If it's 2 theta, it's a circle?
It's a circle on the y-axis now.
And does that only
Two
work for
sine
sine and
theta.
cosine?
Looks like this.
Does that mean with polar sine theta is a circle?
Yeah. Sine theta. Looks like this. Diameter 1.
Do you remember polar coordinates?
I was in
No, we learned about it last year.
No, 2 years ago.
2 years.
Polar coordinates battleship. Okay, moving on. Slope.
That's why you're confused.
Yeah, I don't know how you're drawing circles out of flipping the sine. That's kind of confusing.
It also has to do with the values of sine and cosine being circles. It's a unit circle.
Wait.
Yeah, we're gonna have to do this later. Okay, slope. Okay, remember, slope is always dy dx, correct? here's the messy part. And remember in parametrics, it was dy dt over dx dt?
Mhm.
Okay, because that t is parametric, well, polars is theta, right? The same idea, dy d theta over dx d theta. Okay.
But in polar stuff, you usually only have one equation.
But in polars, what is y equal to?
R.
R
Theta?
sine theta. If you convert
Oh.
rectangulars, remember? And x is r cosine theta, right?
Mhm.
So you are actually using implicit differentiation to grab a polar slope. Okay, so if we differentiate y with respect to theta, we have a product rule, correct? Okay, so derive the first. 1 dr d theta is implicit. And then copy plus
R cosine theta.
cosine theta. Okay. Now what's the bottom gonna be?
Sine theta squared.
So, same deal.
Theta.
dr d theta,
Oh. So we're doing the parametrics then?
cosine theta, plus
R sine.
r negative sine theta, right? So we can
Yeah.
actually change that to a minus. Okay. So you can memorize that, or you can just remember how to derive it. Either way works. Because you already have to remember these two items, right? And if you remember this, you can derive it. That's how I do it, but again, you can memorize that formula if you'd like. But it is a bit messy.
So with parametrics, is it always sine and cosine?
Parametrics.
Or, sorry.
Polars. Yeah. It has to do with the unit circle and right triangle trigonometry.
So we'll never have like a
You should go watch that
tangent or
video.
secant.
No, it can have secants and tangents. How much can you fit in Calc BC? Right? So, okay. So let's, find an equation. Of the line, tangent. Okay, what do you need when you write the line, equation of a line?
The y value, the x value, so.
You need x, y, and you need the slope, right? So how would I find x and y here?
Theta to the original equation.
You just plug an R to the end line equation.
Oh.
X equals r cosine theta, right? So we know theta, what's r?
Sine
Sine
two
two
theta.
theta.
Yeah,
So when it asks for like, when it asks for a line tangent to a a polar is gonna be an XY.
Still an XY, yeah, kinda weird, huh?
Yeah.
Okay, let's sign it 3 power 4. Sorry, 3 power 2, that was dumb. Dum, 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 dum. Do a circle. Half a pi, 1 pi, 1.5 pi.
Oh.
Sign is the y values, right, so. Now let's cosine of 3 power 4.
Ah.
Negative root 2 over 2. Now we're here.
That's where that came
What is y equals?
from. If you just slow down.
That root 2 are gone. Okay, everybody knows polars. Nope.
In polars is like that x equals r cosine theta thing, like,
That's how you convert the rectangular coordinates.
so whenever you have an x, plug in r cosine theta?
If you need an x, if you want to calculate x
Yes.
in rectangular, yeah, you need arc cosine theta.
So since we're trying to find the equation, we have to convert it to r cosine theta.
Everything has to be x, y, and equation of a tangent line.
Okay.
Yeah, that's why we're doing it.
So does y have all those things? as well?
Yeah, arc sine theta.
Sorry.
Alright, now the fun one.
One.
Y d4 d theta.
Oh, it's slow.
dy dx. Okay. What is dr d theta?
R d theta.
2 cosine t theta.
2 cosine t theta. Okay. That's top and bottom, right?
So can that factor out?
No,
Math murder.
because it's not a part of this term.
Oh.
And then we have sine theta plus, and then what's r?
2 sine, or sine 2.
R is sine 2 theta. Whew! And then we have cosine. Okay. Alright, so there's your derivative for dy dx.
Pretty cancer.
If we do this,
Say it's cancer.
Yes.
Yes.
It is. It grew very quickly.
if we do this, will we have to go to this extent, or will it?
Yeah.
That's disgusting.
Okay, now you plug in 3, 5, and 4, right? That's our theta.
Parking rank's too messy. I
Can you just put
So dy dx evaluated at 3 pi
turn the limit
over 4. So we have 2 cosine 3 pi over 2 sine 3 pi over 4 sine 3 pi over 2 cosine 3 pi over 4 over. Hope y'all lifted weights this week because it's a lot of writing. Oh, I mean cosine right there.
Dude, this is the worst time to be in the I actually have to deal with
It took me 60 seconds just to write that problem. Wow.
this. Yes.
Why didn't no? You take like a small break after you're done writing. Thank you.
We got out pulled yesterday for problems.
Okay, a key, one of the keys here is to stay organized. You skip steps, you're gonna skip answers, I bet you. Right? So, be careful. Be very careful.
Wait, can you do that with
What?
trig functions? Can you leave it as like cosine valued at 1, or do you have to evaluate
You
it?
have to actually do the evaluation.
Can't you just like put that whole mess in that?
Here's
spot?
what, it does kind of, this works out. What's cosine of 3 power 2?
Is
Zero.
that
Zero. 0. So if 2 times 0 times, who cares? Right?
Oh, that's 0 and -1.
Which that is actually retained to. Whoa,
Either way, it's 0.
Sine 3 power 2, -1, and cosine 3 over 4.
3 power 2 is pi plus 1/2, so that's 270.
3 over 2.
Then again, you have 0 here.
So power is worse than pi.
Yeah, pretty much.
Terrifying work.
So what you actually end up with is root 2 over 2 over root 2 over 2. You need all that work for $1.
Wow.
For one.
I want to see this $1.
And
Life is the greatest when it is simple.
that wasn't simple.
It's a simple answer.
I grew up.
I'm
Okay,
not
now
gonna
write your
do it.
equation.
Not like this.
The answer go after you this one.
What, 42?
And the longest tangent line equation problem in history is now done.
What is them?
The longest one we've ever done, I guarantee
So-
you that. So what?
If, I'm just trying to think, like, I don't know, for me it always goes back to real world application.
You're right.
Because, like, finding tangent to a circle, I guess, or an arc length, what was that?
Yeah, what?
The real world use for this.
Uh-huh. What about it?
What was it? What is it?
The polar slope?
Yeah. And like finding circumference and stuff, but like,
Something you'll probably never do.
Sometimes they don't help.
what?
What?
Yeah, still, what is it?
Oh, I guess satellites. Use for the tangent, finding the tangent.
Well, if you have a shuttle in orbit of the Earth, right? You can also do this in rectangular coordinates, but if you have a shuttle that's orbiting the Earth and you want it to fly to the moon, right? It's gotta have gotta be tangent to the Earth at some point to get away
Yeah.
from it.
Could work for the same
When
way.
you have the Earth and the moon, straight line between 2 points, or where is the moon gonna be? There's a lot of related rates, there's a related rates problem out there in polar coordinate. How about that?
Is that a real thing that we show them as related rates to the polar coordinates?
No.
Or
But
be like that one over there that said the Earth was
But it
flat.
could, I'm not gonna say it won't. Okay,
Come on,
so,
it's
no,
calculations.
I am not up on my polar applications, but
Rectangular.
they happen,
So,
otherwise it wouldn't bother, I guess. Yeah.
Yep.
Okay.
and time.
well,
Homework.
no.
I'm assuming they make something. It's just everywhere. No.
What?
Because I don't see
Take shower?
Are we commenting about race here?
The blacksmith
Hobby.
Say what?
my hobby.
What?
Blacksmithing. Different time, different standards.
I feel like this is deceiving.
They're probably
It
all
is.
like,
Full of problems, thank you, Mr. Arthur. Dang it.
wait, for the whole
Laughs
weekend?
maniacally.
That problem took a half a page. And again, I would recommend you finish this by Tuesday, because Tuesday night you'll have your test,
You want to do like
okay?
2 in an hour?
No, you will do your own work.
Talking about the homework.
Yeah,
Oh.
you will do your own work. Thank you very much.